Hello, Precalculus. It is time to finish 10-3 day 1 notes. We're on page 3. It's going to be great. There's only one thing left to do, and that is to find the sum of an infinite geometric series. But you can't do that forever because we've been talking since day 1 about converging versus diverging. If it diverges, you're not going to get a sum. It's just going to one of the infinities. So when do we know that a geometric series will converge and has a sum? That's right here. The absolute value of r has to be less than 1. Now, personally for me, the way I think about that is that r has to be a proper fraction. And it does not matter if it's positive or negative, but it has to be a proper fraction. 2/3, you'll get a sum. 3/2, you're not getting a sum. So before you try to use an infinite formula, make sure to look at the r value so we're not trying to trick you. All right, and so here's the formula. A lot easier than the previous formula, so it's first term divided by 1 minus r. Super fast. Some of the problems will come out as perfect whole numbers. Sometimes we get fractions, decimals. They're both possible. It just depends on what you're given. Now, just a quick side note that I think is kind of neat. You can totally ignore it. But if you actually were to look at problem number 7, it's actually asking you to take 7 plus 7/2 plus 7/4 plus 7/8 plus 7/16 and keep doing that forever and ever and ever. So I think these problems are kind of cool because the fact that we actually get a numerical sum that we can figure out is pretty neat. So let's just jump right into the formula. The formula doesn't have a little subscript. I draw an infinity because I think it sounds good and looks good right there. That's not mandatory. So my first term is a 7. 1 minus r. R is 1/2. Now, I would recommend going straight to the calculator. If you do that, be careful. Make sure your denominator is in parentheses or you're not getting the correct answer. If you want to do more work by hand, feel free. That's not mandatory. Again, some of these problems come out awesome. Some have fractions and decimals. This guy was amazing. A perfect 14. So you can add forever and ever and ever, and you can still get a sum. Math is awesome. Next problem is 2 parts. Write it in sigma notation so we can practice what we've been doing since 10-1 day 3. And then actually go ahead and evaluate. Evaluate means give the numerical sum. And you can tell it's infinite. If you weren't looking closely enough, the ... that's telling you it's infinite. But you've been practicing that for several days, so I think you're going to be totally fine with that. So let's do the sigma notation first. Now, before I can do that, because you're going to see problems like this that are arithmetic, you're going to see some that are geometric, and you're going to see some that are neither. So before I can go any further, I have to find the pattern. Am I adding to get from term to term? Am I multiplying? Or is it something else that's random? So in this case, you can see that. How are we getting from one to the other? I'm going to multiply by 2/3. So 6 is 2/3 of 9, 4 is 2/3 of 6, 8/3 is 2/3 of 4. And just a reminder from video number 1, if you didn't know how to find the ratio, take any term and divide by the term that came before it. And if it's the same every time, you know it's geometric and you found the r value. So that's what that takes there. Fantastic. So if you're taking inventory, I don't know if you like that step. Some people skip it, but some people like it. What the heck happened? So the first term was 9, and the r is 2/3. And so let's go to sigma notation. So I'm going to start with 1. I'm going to go to infinity. And then I'm going to use my formula from the first video, which was that finds the terms. And so that formula looks like that. So now let's put that in place. There is the first term. There is the r. And then there's our n minus 1. I'll make that. There, it looks better. So there's our sigma notation. Now we want to evaluate. So I'll just write the formula because I don't feel like scrolling back up. First term divided by 1 minus r. So what color's left? I don't know. So let's go first term divided by 1 minus 2/3. And again, you can go straight to your calculator, but only if that goes in parentheses. And that would be 9 divided by 2/3, which becomes 3 times 9 divided by 2. No, just kidding. I subtracted wrong. I think these days are wearing on all of us. And this one comes out to be a perfect 27. That's great. So I'm going to suggest now, go ahead and pause the video and try numbers 9, 10, 11. And when you're ready, I'll have some solutions for you. And so here's just some mixed practice. So I'll go through these and let's take a look. So is the sequence geometric? So I'm looking for multiplication. So I'm going to get some lighter colors. So on letter A, times 2 times 2 times 2 every time. So I'm going to say yes, it is geometric. And I do know then the R value is a 2. When I look at letter B, that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. That's not arithmetic because I'm not adding the same thing every time. It's not geometric because I'm not multiplying every time. So I'm just going to say no. Next one, I can go times negative 1/3 times negative 1/3 times negative 1/3. So I'm going to go ahead and say yes, it's geometric. And the R equals negative 1/3. And I can look at the next one and go minus 3, minus 3, minus 3 every time. And that's arithmetic, but definitely not geometric. So I can find the D value because it's arithmetic, but I can't find, it's not geometric, so there's no R dimension there. All right, number 10 is just asking for a single term. So remember that you have the rule, the explicit rule to do that. First term times R to the n minus 1. The problem is right now, I know the first term, but I don't know the R value. And so what we can do is, obviously some of you just figure it out in your head. That's totally cool. If you don't know it, just a reminder again, you can take any term and divide by the term that came before it, and you'll realize the R value is times negative 4 every time. And so the next thing I'm going to do is go to my formula that says A sub n. Oh, I already wrote it down in pink. Check it out. We're going to use it. I'll say orange. That's fine. So I want to know the 12th term. So that's A sub 12 equals first term times R to the 12 minus 1. Another reminder, depending on the age of your calculator, if your calculator puts the 12 minus 1 up as the exponent, then you're fine. If your calculator is old and does not kick it upstairs like that, don't forget you would need parentheses on any exponents, just like we did in Chapter 3 and any other time that we've dealt with exponents. So just heads up on that. And now I would just go straight to the calculator. Let's just work horizontally. And this one's gotten pretty big. 786, 432. If you didn't get that, reach out to us and we'll help you out. All right, last one is a sum. It is infinite. Before I calculate the sum, I want to double check this number right here. I have to make sure it's between negative 1 and positive 1, a proper fraction. So it can't be 0, can't be 1, can't be negative 1. Anything otherwise between those is fantastic. So it will have an answer. I'll just rewrite the formula in case you didn't memorize it. And you don't have to memorize it. You probably will just by using it a few times because your brains are amazing, powerful machines. And so we want the first term divided by 1 minus R. You could just go straight to your calculator if you want to. Again, parentheses. And if you don't want to use it, well, you'll probably use a calculator for this step anyway. And then we go to the calc. And did I do this one right? No, I'm second guessing myself. And let's put the answer as 5, and we will finish the day. All right, thanks for watching. Reach out if you need help. See ya.